So these are the last notes of the unit, notes L and M. So get your notes L and M out. They're the last ones in our notebook. And of course, it's always easiest if you can put the video on one side and your notes on the other. So you can pause the video to make sure you're doing that right now. So we're going to start this with a movie. This really talks about Hawaii because not all volcanoes are at boundaries, at plate tectonic boundaries. You know, most volcanoes are because you have subduction. Subduction is when one plate moves underneath the other one, right? And then this stuff bubbles up through and makes a mountain, makes the volcano. But there are these things called hot spots, and Hawaii is a hot spot. So let's see what's going on in Hawaii. I got a short movie for you first.
Hawaii sits in the middle of the Pacific Ocean and nowhere near the edge of a tectonic plate where volcanoes are usually found. So how did the island chain form with all of its volcanoes? The island chain is located over a hot spot fueled by a mantle plume of heated rock. Solid rock at the bottom of the Earth's mantle is heated by the planet's core. That hot rock slowly rises and pushes up the crust, forming a bulge. Under that bulge, some of the rock melts into magma. Magma makes its way to the surface through cracks in the crust. Once it's above ground, it's known as lava. Hawaiian volcanoes produce lava flows made of melted basalt, which is more liquid than lava produced by more explosive volcanoes like Mount St. Helens. Basaltic lava flows form volcanoes with gently sloping sides. A lake of liquid lava can sometimes be seen at the top of active volcanoes like Kilauea. Sometimes the magma can flow underground to the sides of the main vent and erupt out of cracks in the ground called fissures. When lava meets ocean, the island grows, but you may not want to get too close. That steam is hydrochloric acid laced with tiny shards of volcanic glass. The Pacific plate is moving to the northwest, dragging the crust over the hotspot and creating islands as it goes. The hotspot itself might be moving too. The volcanoes on Ni'ihau and Kauai, the northwesternmost islands in the chain, are about 5 million years old. The Big Island of Hawaii is the youngest and started forming about 400,000 years ago. It's still changing and is home to 4 active volcanoes. Eventually, the Big Island will no longer be over the hotspot, and a new island will grow next to it. But maps won't need updating for a while. Lo'ihi won't break the ocean surface for another 200,000 years, give or take. For Scientific American, I'm Kelsey Kennedy.
All right, so let's see. Let's talk about what she was talking about there, right? So here we have oceanic crust. Right, oceanic crust, and maybe in your plate tectonics lab you saw that the Pacific plate is moving to the northwest, just like she said in the video. So this is a hot spot. It's in the middle of a plate. It's just a plume of hot molten material, just in that one spot. All right. So what happens is, obviously you have a volcano that comes out there, but over time, this whole plate here, right, is moving in this direction. So what's going to happen, right? That crust is slowly moving, but the magma plume underneath is not. So what happens is you have this volcano actually is the same one as that volcano. All right? It's just that the crust moved away from that plume. So now it's not active anymore because there's no plume underneath it. So that's just a volcano, an old volcano, but not active anymore. And what's going to happen underneath the hot spot is you get a new volcano. But then time goes on, and we're talking a lot of time, millions of years, right? And then eventually that crust is slowly moving to the side. And then you have this volcano is now over here. It's eroding. It's getting smaller and smaller because it's not active anymore. And then you have the second volcano, right? That's this one, but now it's moved. It's been slid over, and it's not active anymore, but it was just made, so it's a little taller. And now we have a new volcano where the hot spot is. And this just continues on and on as this plate moves. And so eventually we're going to get another one here, right? As this moves this way, and then we're going to get another one here, and that's Hawaii. Hawaii is a series of volcanoes, but only one of them is active. So let's take a look at Hawaii. So here's Hawaii, right? This is where the active volcano is. It's right here, like she said. So this, if you've ever been to Hawaii, there's active volcanoes here. But there are no active volcanoes here or here or here. These are old volcanoes. And they get older and older. This is about 400,000 years old. This is about 1 million. This is like 4 million years old. And here's 5 million years old. As you get away from Hawaii, they get older and older. And they get smaller and smaller because they're getting eroded. And actually, these islands go all the way to Midway, and they get so small they're at sea level. But, we can ask this question now: how fast is Hawaii moving over the hotspot? How fast is that plate moving? If you recall, the Atlantic is growing at about 2 centimeters a year, but we can figure this out. Think about this. So how fast is moving? How do we calculate speed, right? Speed is distance over time. That's all speed is, distance over time. Well, we have the distance, right? So where do we have distance over here? We could use any of these, but let's just use these values right here. We have a distance and we have a time, right? So there's our distance and there's our time. So we can just take the 510 kilometers. That's how long it's taken for that island to go from there to here. It's been 510 million because when it was here, it was being made. So that was 0, just like seafloor spreading, right? And how long did it take to get there? 5.1 million years. So all we have to do is do the math there, and we end up with 0.0001 kilometer a year. Well, that's a tiny number, but that's kilometers, thousands of meters. Why don't we just translate that into meters per year? And so to do that, there's 1,000 kilometers in a meter. We just have to take this decimal and move it 3 times. 1, 2, 3. If we put the dot right there, we're going to get 0.1 meter a year. Well, how big is 0.1 meter? That's 1/10 of a meter. Well, there's 100 centimeters in a meter, so 0.1 meter a year would be 10 centimeters a year. That's about 5 times faster than the Atlantic. But that means that Hawaii and all those islands are moving over that hot spot at 10 centimeters a year. Pretty cool.